So now we're going to look at a problem with liters of NO2 gas to moles. So the key whenever we're using volume is we have to have a gas. We can't do this if we have a liquid volume or a solid volume, only for a gas. So in this problem, we're given liters of NO2, and we're going to go to moles of NO2. So our roadmap, we're going to go liters of NO2 to moles of NO2. So let's take a look at our mole map. So here we have liters of a gas, or volume of a gas, going to moles. This is where we use the 22.4. Now sometimes these problems could be in like milliliters, so you'd have to convert to liters in order for it to work out. So we're using the 22.4 liters in this problem. So we're going to set this up exactly the same. The nice thing about the mole conversions are we set them up all almost identically. So we have liters of NO2. So liters of NO2 are going to go into the denominator. So then in the numerator, we're going to have moles of NO2, which is what the problem is asking for. So 1 mole of NO2 is going to be equal to 22.4 liters of NO2. So because it's on the bottom, we're going to take 0.53, divide by 22.4, and that will give us moles. So we have 2 sig figs here, so I need 2 sig figs in my answer, so it should be 0.024 mole of NO2. In the next one, we're doing the opposite. We're going from moles of hydrogen gas to liters of hydrogen gas. So our roadmap looks almost identical. So again, we're using that 22.4 liters from our mole map. So we're taking 2.3 moles of hydrogen gas. Remember, hydrogen is in Brinkelhoff. So hydrogen gas would be H2. So we're going to have moles of hydrogen gas on the bottom. Oops. And we're going to have liters of hydrogen gas on the top. So 1 mole is equal to 22.4 liters of hydrogen gas. So in this case, we're going to take 2.3 times 22.4, and that will be equal to 52 with sig figs liters of hydrogen gas. So again, your sig figs, we have 2 here, so we need 2 sig figs in our answer. We have to round appropriately like always. Things to keep in mind when I'm grading these types of problems. I am going to be looking for this t-table. The t-table is meant to help you organize the information you have. Otherwise, you're going to have to memorize when you multiply and when you divide, which for a one-step problem would be pretty easy. But once we start to get into more complex problems, you're going to get very confused very quickly. So keep in mind, I want you to practice with your homework using these t-tables. So why don't you try the last one on your own? We're going from grams of oxygen gas to mole. So in this problem, you're working with the mass of a gas. So the mass, you would still use the molar mass on the periodic table. So don't get tricked into thinking when you have a gas, you automatically use the volume, because you're not always given or you're not always looking for the volume. So, and because oxygen is part of Brinkelhoff and is a diatomic, you need 2 of them. So the mass of oxygen will go on the bottom and moles of oxygen will go on the top. 1 mole of oxygen is equal to 32.00 grams, because the molar mass of 1 oxygen is 16.0. So then we can plug that into our calculator. Notice we need 2 sig figs in our final answer because O2, or our initial mass here, has 2 sig figs. So my final answer would be 0.25 mole of O2.